Hello everyone, my name is Ritika Sharma and I am basically BSc BTech MTech and I am basically dealing with the classes 9 to 12th. So today we will take a topic of grade 9th which is basically Newton's second law of motion, right? So the topic of today's discussion is Newton's second law of motion. Okay. So before moving in deep in this topic, let us just take a short review of this particular chapter. And the name of this chapter, you know very well, is what? Forces and laws of motion. So the chapter name is Force and Laws of motion. So basically, force is very familiar word to all of us. In grade 8, we had studied about a force. So what is force? Push or pull an object is basically called as force, right? So push and pull an object is called as force. And what is the direction of force? The direction in which the object is pushed and pulled is basically called as direction of force. And we also know that a force will only come into existence when there is an interaction with the object, right? The SI unit of force is Newton. The SI unit of force is what? The SI unit of force is Newton. And the CGS unit of force is dyne. What? CGS unit of force is dyne. And what is the relation between this SI or the MKS and the CGS is what? That 1 Newton is equals to 10 to power 5 dyne. Okay, and you know that force is a vector quantity because it has a magnitude as well as direction, right? So before moving in this second law of motion, let's check a quick review of the very first laws of motion. So the first law of motion, you know that when we deal with the first law of motion, there is a very beautiful word which is termed as inertia, right? Inertia. And what is the statement of the first law of motion? That a body at rest will remain at rest, a body in motion will remain in motion until and unless an external force is applied to it, right? ओके दैट मीन्स कोई ऑब्जेक्ट है वो रेस्ट पे ही रहेगा, कोई ऑब्जेक्ट है वो मोशन में ही रहेगा, कब तक? जब तक कि आप उसके ऊपर बाहर से कोई एक्सटर्नल फोर्स नहीं लगाते हैं, जब तक, राइट? ओके, so there is a word which is called as inertia. That means the ability or the property of an object to resist any change, right? And this is basically of three types. We had know that three types: inertia of rest, second, the inertia of motion, and the last we have inertia of direction. And an object have a more mass will have a more inertia, an object having a less mass will having a less inertia, right? So the important thing which is to be noticed in this first law of motion, that inertia, so mass is a measure of inertia. And the inertia of motion is a measure of direction. So mass is a measure of inertia, and mass is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of inertia, and direction is a measure of direction. So mass is a measure of This is basically a quick review of that first law of motion, right? Now let's begin about the second law of motion. So, second law of motion. In that first law, we had gone through a word called as inertia. Similarly, in a second law, we will come across a word which is termed as basically what? Momentum. Momentum. Like suppose that you have a ball, okay, and you know that this ball, if it is moving, will have two special property. The very first is what? The very first is the mass, and the second is the velocity. Mass we write with a m and the velocity by v. So if an object is moving, we generally say that it has generally two properties, mass and velocity, and rest pe hai, so it will have an initial velocity, we will take that as a zero, right? So the product of this mass and velocity will give you a new physical quantity which is termed as what? Momentum. So what is momentum? So what is momentum? The product of mass and velocity. The product of mass and velocity is called as momentum. Okay. And the symbol for this momentum is what? P. Therefore, if I write this entire sentence mathematically, so this will be P is equals to mass into velocity, or you can say P is equals to m into v. This is what? Momentum, right? Okay, let's check that what is the unit of this momentum. You know that the SI unit of this mass is kg, and the SI unit for this velocity is meter per second. Therefore, the SI unit for this P, the SI unit for this P is what? Kg meters per second. So momentum, product of mass and velocity, SI unit is kg meters per second, and the symbol is what? P. Okay. Now let's check the statement of second law of motion. So the statement of second law of motion is that the rate of change of momentum or linear momentum is proportional to the external force applied. Either you say a momentum or linear momentum, this means the same thing, that because they are moving on a straight line, right? So let's write the statement of this second law of motion, which is that the rate of change of linear momentum is proportional to the is proportional to the external force applied, is proportional to the external force applied. So if we want to write this particular sentence in mathematical form, so how we'll write? Let's check word by word. You know that this rate means upon time, right? And the change, and the change is always between two quantities, right? That means there must be a final momentum and there must be initial momentum, right? So this change is between two quantities. One is the final momentum and the another one is what? Initial momentum, right? Proportional, the symbol for proportionality is what? This. And for the external force, we will use this F. So if I write this entire thing in a mathematical form or in an expressive form, I can write what? I will write change of linear momentum. It is a rate, therefore upon time will be there. Upon time is proportional to force, right? And suppose that you have a ball. The mass of this ball is m. The initial velocity, you know that the symbol is what? U. And the final is v. And momentum is product of mass and velocity, right? So if I write this, I can write this as what? Change means between two quantities, final and initial. So I can write this change as what? Final momentum minus initial momentum upon time proportional to force, right? So final momentum will be what? Final momentum will be mv, right? Because final velocity will be there. And if you talk for the initial momentum, it will be mu. And the change is final momentum and initial momentum, right? So here I can write what? mv minus initial is what? mu. For time I'll write t, and for this is f. I hope this is quite clear to you, right? Okay. So what is common in that LHS? The common is what? M. So I'll take m outside. The expression in the inside will be v minus u upon t proportional to f. And we know that what? Acceleration is what? V minus u upon t, right? So I can write this entire box as a, right? So this expression will be turns to what? ma, because this is what? This is a. Okay, so ma proportional to f, or you can write this as f proportional to ma. And you know that when we remove the sign of proportionality, we have to put a equal to, we want to put a equal to, therefore we have to put a constant, right? So the constant I can write as what? F is equals to constant ma. Let's take the name of this constant as k and the value of this constant as 1. So I can write this as f, I can write this as f is equals to kma, where k is a constant and the value is 1. Or you can write here the value of k is equals to 1. So this will be what? This will turns to f is equal to ma. So the second law finds the relation between force, mass and acceleration, right? Okay. We know that the SI unit for the force is what? Newton, right? For the mass, we know that it is kg. For the A, it is meter per second square. That means we can write what? That Newton is equals to kg into meter per second square. And how will we define 1 Newton? 1 Newton will be equal to 1 kg into 1 meter per second square. That means on a body of mass 1 kg, when we apply a acceleration of 1 meter per second square, we get a value of force equal to 1 Newton. Okay. So this is for today's session, ending you with a good note. So taking a goodbye, and please keep on studying because study makes your bright future. Thank you and take care.